to run over and over. So we've got timer equals millis. In other words, we're going to take the value now and store it. For long I, so we're declaring I in context right now. Okay, so we're just making I a long. We're going to set it to 0 initially as long as it's less than cycles, which is 100,000. Good thing it's long, by the way, right? If you're wondering how I came up with that bug code at the beginning, it's because I tried to do this and I forgot that I couldn't be an int. So, oh, that makes another good exam problem. So anyway, I used one of my own bugs. So I less than cycles, continue doing the for loop, and add 1 to I after each for loop. And then finally, period equals millis minus timer. So however long this takes, the free running clock inside of the Arduino is going to keep incrementing time, right? So millis will be greater than what timer was before we started the for loop, and that will be period. That will be how long it takes to do whatever we do in here 100,000 times. Does that make sense? So the question, if we go back to the question, what does it say? Approximate time required to print hello to the serial monitor. Okay. Contrast this with the time required to change an output pin from high to low, then back to high again. Let's start with the pin, because that's pretty easy. It says put your code here, so we can. We'll do that. So we'll say digital write. I think it's digital dot write. No, it's lowercase d. And not dot. There we go. Digital write, we've got an output pin already. So we'll write output pin high. And then we'd like to make it low again. There we go. So that's one of the questions. How long does it take to go from actually from high to low and then back to high? So I did it the wrong way. Technically that should be first, though it really shouldn't make much of a difference as far as how long it takes. And if we wanted to, we could run this code and see how long it takes. What we may want to do is do this. We could simply copy this code, paste it, and now we're resetting the timer, right? We've done this with the output pin. Now we're resetting the timer. Let's do it again, but this time, let's serial print hello to the terminal. You see what I'm doing? So the first time we go through the code, or as we're going through the loop, we'll note the time. It's kind of like starting a stopwatch. Okay, run through turning a pin off and on 100,000 times, and then find out how long it took. So stop the stopwatch essentially and print that out. Then what we'll do is do the same thing again, but this time printing hello to the screen instead of turning on and off the digital output. Now there may be a problem here. I'm trying to declare I again. It may not like that. I'm not sure. Let me do a syntax check. If it doesn't like it, I'll just use a different variable. What I'll do is simply use in or something. Output pin not declared. Because I didn't use output pin, I used output pin. Try that again. Typing problem. And looks like it's going to go, so I'm going to go ahead and grab an Arduino and we'll actually run this. See how long each takes. Why did I make it 100,000 times? Do I really have to? No, millis is accurate enough that I could do it many fewer times. But what if it takes part of a millisecond to do it? If there's variation in the amount of time required to do this. Well, maybe doing a lot would help. Oh, getting a cable that connects would also help. You guys have an Arduino cable handy? Yeah, don't that's the end I need. Okay, so let's download that. 100,000 times may be far too much. I don't know. We'll see. Oh, it helps to tell it where the Arduino's at. Oh, it says it's on COM 1. Let's see if it works. It's not going to work. Error code uploading the sketch. Let's try one more time. There we go. Done uploading. So what is it doing right now? Good question. I've got the baud rate set wrong. Let's find out. Okay, so it's printing hello to the screen. Now I don't know how many hellos we've got, but this is taking a while. So we might wait for about 30 seconds, and if it's still going, instead of running 100,000 times, we'll run fewer times. Now, we've got a small problem. Apparently it did the digital writing of the pins very quickly, and I didn't get to see it, right? So, I probably will not get to see this in any case. Probably the better thing to do, let's see, would be to do this separately. What I'll do is just take this out.
Question?
Yeah.
So put in a variable up for your first millis count, set it as 1, and then put another variable up for your second millis count, and then at the very end of all of that, print those two variables next to each other.
Right, I think that would be the best, but since it's a loop, what it'll do is it'll go back and continue. So maybe the best way to do, like you're saying, you're right, you're on the right, I think you've got a good idea there. Let's make period 1 and period 2, because we really don't care about timer, right? So what we could do is instead of serial printing here, cut it, and we'll just do a while loop. That way it gets stuck here. While 1, in other words, always do this. And I don't remember if I need a curly bracket or not. I think I do. Yep, I do. While 1, serial print period 1. And serial print period 2. So we'll have a period 1 and a period 2. We don't need this serial print. Should be fine. Let's see, so I need another variable declaration. Period 1, period 2. Uploading, there we go. Right now, for that short time, it was turning the output on and off. Okay, now it's printing hello, and hello is taking forever, right? We noticed that took forever before. How about if we just try 10,000? See what happens if we only run 10,000 loops instead. Okay, so it apparently ran, there it goes. All right, so we got 2797 and 93. Those are the two numbers. So it took 93 milliseconds to turn a digital pin on and off 10,000 times. It took 2,797 milliseconds to serial print, or I'm sorry, yeah, to serial print hello 10,000 times. Okay. We expected that, right? You would fully expect for the serial printing to take much longer than the digital writing. What would happen if we turn the baud rate down? What do you think will happen? Right, the baud rate is at 250,000. Will it change? Let's try. Let's try 74,880. So let's see, 74. 880. It's uploading. There we go. We'll auto scroll. Now it looks like it's printing each hello very slowly, but it's not. Still took 93 milliseconds for the digital write, but now it took 9,441 milliseconds for the serial printing because we were sending characters one at a time more slowly across the serial port. Okay? Anyway, interesting things to think about. So now we can contrast the two. We can say how much time, or say there's a, calculate the ratio of the 93 to 27, 67, or whatever number it was we had. Interface a switch and motor to the Arduino. Create a program that performs the following. Supposed to print, ready to test your response time. I think we did this as a lab, didn't we? Something like this? We didn't? Okay. Stuck in my mind for some reason. We were doing something with response time. Oh, I know what it was. It was the LEDs moving around. That's right. Okay. So it has to print, ready to test your response time to the serial monitor, wait for the user to press a switch, and then it has to print plain. After a random amount of time, and that random amount of time should be between 0 and 5 seconds, turn on the motor, make it turn at a random speed between half and full speed. Well, if it's a DC motor, how are we going to make the motor turn at something between half and full speed? Pulse width modulation command, an analog write command would be the way to go. Measure the amount of time until the user presses the button again after the motor was turned on. So you're going to have to note the time, just like I did in that sample code, right? This is why I made this way, because it matched nicely with the previous one and gave you some hints. You'll have to basically start the stopwatch, note the time when you start the motor, when you turn the motor on, and then note the time when the user presses the button. Print the time for this trial and the best or lowest time since it was reset, and then go back to step one. So going back to step one is pretty straightforward because that's going to happen naturally in the loop function, right? How would we approach this? What would we do? What would you do? I would suggest you try it. Let me show you how I would attack the problem. I would grab the IDE, and I would just basically copy what we've got here. So let's see, I know this all has to happen in loop because it has to happen over and over again. So I'm going to clear out the code that's in here because I don't need it. I'm just going to write it as print ready to test your response time. That's what I want to have happen. Wait for user to press the switch. Obviously, this is not going to work, is it? This is just pseudocode. This is just writing down what I want to have happen, because it's a pretty straightforward do this, then do that, then do the next thing. If I write it out this way, the structure of the program will already be in place. Okay, what else? Then we have to print plain. On the serial monitor. Okay. Random amount of time. So I'm going to have to generate a random amount of time. Let's note that. What does it mean to generate a random amount of time? That means I'm going to need a random number generator. I'm going to have to store that time in a variable so I can use it later. That's what it means. Let's see. After the time has elapsed, let's see, turn on the motor. Was it between? Yeah, somewhere between full and half speed. Now wait a second. We weren't told exactly what speed to run it at. How would we decide? We need another random generator, don't we? Could we simply use the amount of time? Sure, if you really wanted to. You could use the random number you got in the time. And so basically, if the time's going to be 3 seconds, then the motor turns on at 3%. If it's 5 seconds, 5%. You know, you could do that. But probably the intention is to generate another random number that's not coupled to the amount of time. Print the time for this first trial and the best, or, oh, we're not done yet. We skipped step 4. Measure the amount of time until the user presses the button again. So basically what we have to do is wait until the user presses the button. But, oh, we forgot something. Don't we need to also note the time when the motor was turned on? We have to do that too. You see how I'm expanding what I was given? I'm thinking through it and trying to think of, okay, what do I have to do to make this work? And adding that in so that I can change all this English code into Arduino code. Measure the amount of time until the user presses the button again. So they're not starting the game, they're pressing the button to play the game. Print the time for this trial. Well, once the user has pressed the button, we have to take difference between start time and now time. Right? Because now is when the user has pressed the button. What next? Okay, so print the time for the trial and the best. So we're going to have a high score variable. So probably we need to initialize a high score variable. Real quick hint for you guys. One thing I noticed is that students typically can get through the questions that you write in answers to or calculations pretty quickly. That should only take you about 30 minutes. That way you've got about an hour and a half to spend on the program, because the program should take a decent amount of time. I just looked at the camera to make sure I don't run out of recording time. I will post this for the Anderson students because you probably can't read it on the screen very well. Okay, let's see. Take difference between start time and now time. And then we were supposed to print current score and also print high score. Okay, and then it'll naturally go back and start over again, so that should be all we need. Go to step 1. So now I have something that I can start working on, and hopefully I'll have a structure of code that will actually function. Now obviously I can't print ready to test your response time this way. I have to use serial.print. Okay, I probably would like to print a line. Let me get this cable out of my way. The Arduino was still plugged in and blocking the keyboard. So I'm going to serial print line like that. Now we have to wait for the user to press the switch, so we need a switch connected. So how about if we define input pin, and we'll just use pin 4. Why pin 4? Well, pin 0 and pin 1 are used for serial communications with the Arduino. So most people try to avoid using that. That way you can, for digital input, that way you can have a serial monitor connected and doesn't interfere with your I/O pins. So people will use pin 2 and 3. The only problem with pin 2 and 3 is that they are pins that are used for interrupts. So if you're trying to write code that does not use interrupt pins, then you probably want to avoid 2 and 3 because you might want to use 2 and 3 later for an interrupt function. In our case, where we told what we had to do, your program must use an interrupt routine to sense all switch presses. Oh, so maybe I better go back and actually use pin 2 or pin 3, you see. All right, you see how I would go through this and just code it. There's going to be places where all I have to do is do this, but how do I wait for the user to press a switch? Well, since I have to use an interrupt service routine, what I could do in the interrupt service routine is just set a variable whenever the switch is pressed. So what I could do here is say while, let's say button, and end it. Now what on earth am I doing here? How is this going to work? Well, I'm going to have an integer or a Boolean, it doesn't really matter. Why don't I make it Boolean? It's an on-off thing called button. And I'll set it low to begin. But I'm going to write an interrupt service routine, and I'm not going to go through this. Let me just pretend I'm writing the interrupt service routine here for you, okay? I guess I'll write part of it, void ISR. I probably need something in here, I'm not worried about it right now. I'd go back and look at other code where we've written interrupt subroutines to make sure I get it set up right. But all I would do is, when this is called, I would just set button high. Okay, so I've got to do the interrupt attach and all of that, right? So that this is actually called when the button is pressed. But what will happen is in the loop, the code will get stuck right here, right? Button is not true, it's false. Because that's the way I set it up initially. So it'll just stop right here. It'll just keep checking this variable button. Now this is not a very good way to use an interrupt service routine, but it is a way to use it. Usually interrupt service routines are useful when you have to have the code doing something else. I'm just making the code stop here. It's not really stopping, it's continuously looping through the while. Anyway, as soon as the interrupt service routine is called, because the button is pressed, well then button will go true. And actually I've got to do this the other way around, don't I? I've got to set it as false. And initially is true. You've got to think about it backwards. So what while is going to do is going to look at whatever's inside the parentheses, see if it's true or false. That's what it thinks of 1 and 0 is. 1 is true, 0 is false. So it's going to, since button is equal to 1, it's saying while 1, while true, stay in the loop. Okay, I'll stay in the loop. As soon as the interrupt service routine sets button to 0, now button is false. As soon as while gets back to checking button, which it'll get back to very quickly, it'll see that button is false, so it'll say while false, okay, not true, exit the while. Yes?
But it seems like you're doing an extra step there.
I agree. I think the better thing to do is to simply say while digital read of the switch is false.
Well, why are you using the interrupt service routine?
The only reason I'm using
the
only reason I'm using it is because this said I had to.
Right, but why not use the interrupt service routine to immediately call, or use the interrupt to immediately call the interrupt service routine and have the code written inside that?
Why don't I put the game in here is what you're saying? Because that's not the purpose of an interrupt service routine. Interrupt service routines are supposed to do something quickly and exit. They're not supposed to be long bits of code.
Right, but well, I guess what I'm saying is to call the function that would be to finish out that. So have your interrupt service routine written in a void loop, right, and then have the interrupt service routine or the interrupt call that function.
I think you're getting confused. I think what you're thinking of is what you normally call a subroutine. You're thinking the interrupt subroutine should be a classic subroutine where the subroutine is the game, kind of like think of a video game. Okay, you've got the attraction screen, right? Something that's playing music or has a video playing. Teenage Mutant Ninja Turtles, you got to rescue whatever, right? And as soon as the user inserts their coin and presses the start button, now let's go to a subroutine that is the game, where you're playing the game, you're fighting the bad guys, and you exit that subroutine, you go back to the attraction screen. I think that's what you're thinking of, because that's a classic subroutine. Interrupt service routines are not supposed to be subroutines, although that's kind of like what they are. They're supposed to be little bits of code that do a small thing and then exit immediately. Does that answer the question? I don't feel like it does. Can we try again?
Shut up. Okay.
How would you do it? What would you do?
So, I would use the interrupt function.
Down here, where I've got button highlighted?
Right, so instead of changing the value of button,
Okay, what would you do instead?
I would call the void loop portion.
So you say go to loop. Something like this. I know the syntax isn't something that this is what you're saying you would do.
Right.
If you do that, it would go right back up here and start again. You get down to the while again. I think, again, I think you're trying to use this interrupt service routine to go into a subroutine. And there's something else to think about here that I haven't taught you guys about called the stack. Every processor has a stack, and the stack is basically a section of memory where it can temporarily place things. It uses the stack for things like instruction pointers, like where are we at in the code. It has to remember that. See, computers are actually very, very stupid. They're machines. They have no thoughts. They have